Hello students, hope you're all doing well. Welcome to another video by Quick Study. Today we will start another topic of GCSE Physics, and our topic for today are light waves. Light waves are a type of electromagnetic waves. We have already learned about electromagnetic waves in our previous video. They exhibit properties such as reflection, refraction and diffraction. Let's look into these properties. So first one would be reflection. The bouncing back of a light when it hits a surface is known as reflection. We already know about the law of reflection, which is the angle of incidence equals to the angle of reflection. Let's look at a problem. A light ray hits a mirror at an angle of 30 degrees. What would be the angle of reflection? So, as the angle of incidence is equal to the angle of reflection would also be 30 degrees. So in this figure, a light wave is being reflected back to the same surface. This is known as the reflection in light waves. Light is reflected from a plane mirror, and the angle of incidence is equal to the angle of reflection, the normal line at right angles to the mirror. Always remember to draw the normal at first before drawing the incident or the reflected ray. Let's look at the second property, which is refraction. Refraction is the change in direction of a wave passing from one medium to another, caused by its change in speed. Let's look at this figure to understand it better. In this figure, the incident ray is traveling from air to glass. So while traveling from air to glass, it is refracted and it bends and then comes out into air again. But when it is coming out, the original direction of the ray would be straight, but it is not. Now it is bent. This bending of waves while passing from one medium to another is known as the refraction. You can take a screenshot of this figure to understand how to draw a refraction of light. Before we do calculations about light waves, we need to know about the refractive index. The refractive index of a medium is a measure of how much the speed of light is reduced inside the medium. For example, the refractive index of glass is about 1.5, but of water is 1.3. That means under similar circumstances, glass will refract more than water. The refractive index is derived as n, and there is a formula for it. N is equal to sin I by sin r, where I is the angle of incidence and r is the angle of refraction. Let's look at an example while using this equation. In an experiment, the angle of incidence was measured as 30 degrees and the angle of refraction was measured as 19 degrees. We have to calculate the refractive index of the glass block. So the formula is N is equal to sin I by sin r. So sin 30 divided by sin 19 would come out as 0.5 divided by 0.33. The answer would be 1.52. To understand how refraction occurs in light, we have to understand the bending of light. Light bends towards the normal when it enters a medium with higher refractive index. Similarly, light bends away from the normal when it enters a medium with a lower refractive index. That is the characteristics of a regular refraction. One of the most interesting characteristics that light has is known as the total internal reflection. It is a phenomenon that occurs when a wave traveling through a medium encounters an interface with a less dense medium at an angle greater than the critical angle. The critical angle is the angle of incidence above which the total internal reflection occurs. It is specific to the pair of medium which it is occurring in. This results in the wave being completely reflected back into the original medium rather than being refracted into the second medium. So let's look at a figure to understand it better. We must remember that total internal reflection occurs when the angle of incidence exceeds the critical angle, causing the wave to reflect entirely back into the original medium rather than refracting into the second medium. There are some conditions for total internal reflection, which are the wave must travel from a denser medium to a less dense medium. For example, from water to air or from glass to air. The angle of incidence must be greater than the critical angle. For angles less than the critical angle, partial reflection and refraction occur. Here in the first figure, that is what is happening. Partial refraction is occurring in the first figure. For angles equal to the critical angle, the refracted ray skims along the boundary. In the second figure, it is happening that the refracted angle, the refracted ray is basically the same as the critical angle. But when angles greater than the critical angle, then the total internal reflection occurs, only when the incident ray is greater than the critical angle, created by the total internal reflection of light in layers of air with different temperatures. Temperatures might play a crucial role in total internal reflection, but often we do not take it into consideration. There is also a formula for which we can calculate the critical angle, which is sin C is equal to 1 divided by the refractive index. Let's look at an example to understand it better. The refractive index for a type of glass is about 1.45. We have to calculate the critical angle. So sin C is equal to 1 divided by n. So sin C is equal to 1 divided by 1.45. Sin C is equal to 0.69. So when we inverse sin to the critical angle, the answer would come out as 43.6 degrees. There is another problem given in here which you can try to solve by yourself to understand if you have understood all the things regarding the light waves. In this experiment or the problem, we have to calculate the refractive index and also the critical angle. So we have to use both the formulas that we have learned. That's all for today, students. Let's recap what we have learned. We have learned about how reflection occurs in light and refraction occurs in light. We have also learned about total internal reflection and the critical angles. We have learned two new formulas, which is for the refractive index and for the critical angle. I hope you have understood all the things properly. Stay with us to learn more about IGCSE Physics and other subjects as we regularly post on our channel. To learn more about our online tutoring service, do visit www.quickstudy.uk.